Hello everyone, my name is Mr. Asnake Halu and I'm a physics lecturer at Awasa University. In this session, we will be tackling past entrance exam problems together. I hope this will boost your confidence for the real exam. እኔ መምህር አስናቀ ኃይሉ እባላለሁ። በአዋሳ ዩኒቨርሲቲ በፊዚክስ የትምህርት ክፍል መምህር ነኝ። የባለፉ ዓመታት ዩኒቨርሲቲ መግቢያ የፊዚክስ ፈተና ጥያቄዎችን አብረን እንሰራለን። ይህ ለዋነኛው ፈተና ያዘጋጀናል ብዬ አምናለሁ። ጥሩ። Today we will start from number 7. Already we did till number 6 on our previous session. And now number 7 says, which of the following statement is not true? About what? For a wave motion. Dear my students, remember what you are learning about a wave, or simply about a mechanical wave and an electromagnetic wave. Mechanical wave requires material medium for its propagation. Any reverse electromagnetic wave not necessarily require material medium. Great. On the behalf of that, can we see the alternate to decide or to find the fault about the wave motion? Great. Here, mechanical transverse waves can propagate through all medium. Mechanical transverse waves cannot propagate through all medium. For instance, mechanical transverse wave cannot propagate through the vacuum. B. Longitudinal wave can propagate through solid, of course. 3. Mechanical transverse wave can propagate through liquid. Yes. Transverse wave can propagate through vacuum. Definitely. Electromagnetic wave is one of the transverse wave, and then it passes through, or it can propagate through or via vacuum. This is right. And then our answer is, or default one is choice A. Choice A is completely false. Look, in conclusion, no mechanical transverse wave or waves cannot propagate through all mediums. Mechanical waves require a material medium to transmit their energies or energy. This means they need particles or material mediums that can vibrate and then interact with each other. Therefore, mechanical transverse wave cannot travel through vacuum, which is region devoid of matter. Great. Number 8 says a ball is in free fall. Its acceleration is, it says. Before that, we have to know the meaning of free within a free fall and then fall within a free fall. Great. Free. The word free within a free fall means the only force which acting upon the object is gravitational force. So the word free tells indicates that within a free fall. But fall means or it does not mean downward in this case. Okay, in this case ይህ ማለት ቁሱ ወደ ላይ ለምሳሌ በ40 ሜትር ፐር ሰከንድ ቢወረወር እንዲሄድ ቢደረግ በእያንዳንዷ ሰከንድ 10 ሜትር ፐር ሰከንድ ፍጥነቱን እየቀነሰ ይሄዳል። እኛ ለማየት አልቻል ይሆናል እንጂ በእያንዳንዷ ሰከንድ ቁሱ ወደ ላይ ቢሄድም እየወደቀ ነው። ባይወርቅማ ኖሮ ተመልሶ እንዴት በእጃችን ወይም ወደ ወርዋሪው እጅ ሊመጣ ይችላል? ስለዚህ ወደቀ ስንል ትርጓሜው ወደ ላይም ሲሄድ ወደ ታችም ሲሄድ ይህ ክስተት ይኖራል። ግን ወደቀ ስንል እኛ ቀድመን የምናስበው የሆነ ነገር ከላይ ወደ ታች ስምዘገዘግ ሄይቱ ወይም ርቀቱ ወይም ወደ መሬት እየቀረበ ሲመጣ ወደቀ እንላለን። ወደቀ ወደ ላይም እየሄደ ይከሰታል። በመከሰቱ ምክንያት ነው የወረወርነው ዕቃ ተመልሶ የሚመጣው። በመከሰቱም ነው ማክሲመም ሄይት ሲደርስ ፍጥነቱ 0 የሚሆነው። ይህን ልናውቅ ይገባል። ስለዚህ ፍሪ በዚህ ቃል ውስጥ የሚገልጽልን ቁሱ ላይ አክት የሚያደርገው ተጽዕኖ የሚያሳድረው ብቸኛው ፎርስ የመሬት ስበት መሆኑን ነው የሚነግረን። ይሄ ፎል ቅድም እንዳልኳችሁ ጥሩ A downward alternate says downward during both ascent and descent. Yes, its acceleration always downward. Acceleration due to gravity always downward during both ascent and descent. ቁሱ ወደ ላይም ወደ ታችም በሚመጣበት ጊዜ የቬሎሲቲው አቅጣጫ ይቀየራል እንጂ የአክሰለሬሽኑ ወይም አክሰለሬሽን ዲቱ ግራቪቲው አቅጣጫ ሁልጊዜ ዳውንዋርድ ነው። B. Downward during ascent and upward during descent. This is completely wrong. C. Upward during ascent and then downward during descent. This is completely wrong. And then D. Downward at all times except at the very top when it is 0. When it is 0. No. Wherever the acceleration due to gravity is downward, at the mid, at the top, at the beginning, the acceleration due to gravity direction always downward. And then the answer is A. Look, no, the acceleration due to gravity does not become 0 at the maximum point of an object's journey. Therefore, acceleration is the rate of change of velocity. Even though, despite the fact that the velocity is 0 at the maximum point, the acceleration due to gravity is still acting on the object, pulling it back towards the center of the earth. Great. This acceleration is constant and has downward direction. Its magnitude is approximately 10 meters per square of second, and then its direction is downward. Therefore, while the object's velocity is 0 at the highest point, the acceleration due to gravity continues to act on it, causing it to change direction and then start falling back to the center of the earth. The answer, as I said, from this conclusion is A. Great. Number 9. Which element is correct about the pressure under a fluid in container? Okay. In container. Can we see the alternatives one by one? It depends on the volume of the fluid. It depends. Pressure does not depend on the volume of the container. Okay? It depends on the density of the fluid. Of course, it depends on the density of the fluid. We will see. It is dependent of the depth of the fluid. Why not? Pressure depends on the depth of the fluid. Okay? The alternate D says it depends on the shape of the container. This is completely wrong. Anyhow, I will show you something. Look, pressure, as you know, is equal to weight of the fluid within the container and then over area of the container. Great. Look, its weight of the fluid means simply mass times acceleration due to gravity over area. Great. Its mass of the fluid or the water means is simply the density times the volume is known as mass of the fluid. Great. Times G is the weight of the fluid. Great. Look here. The volume means simply the area of the container times the depth. Great. Look here. Areas cancel out. And then it becomes rho GH or rho HG. From this we understand something. The pressure within the container depends on the density and then H. G is constant. Okay, G is constant. G is constant. Therefore, our answer is definitely B. If you change the fluid, that means you are changing the density, despite the fact that the depth is the same, but at the end the pressure at that depth not the same. It could be high, it could be low. Great. So, explanation. We will see the explanation. Look. Pressure in a fluid increases with the depth. Yes, and then depends on the weight of the fluid above it, of course. Denser fluids exert more weight per unit volume, so the pressure at a given depth is higher in a denser fluid. Now number 10 says no work is done if I will give you the explanation on each what we call it alternate. It says displacement is zero. If the displacement is zero, as we know, work is equal to force times displacement, or the dot product of the force and then displacement. That is Fs and then cosine of theta. Great. If the displacement is zero, definitely no work is expected. And hence, displacement is zero, yes, there's no work. Second one is force is zero, yes. Already we said work is equal to Fs and then cosine theta, or the dot product of the displacement and then force. If so, if the force is zero, the product becomes zero. That means if there is no force which acting upon the object, we never expect the displacement of the object. The object never displaced. From this we understand something. No work done upon the object. And as we never expect work here. B is correct. A force and displacement are mutually perpendicular. If the two quantities are mutually perpendicular each other, no energy or no work done on the object. Why? Because cosine of 90 degree or pi over 2 is 0. 0 times Fs becomes 0. Okay? So the answer is D, all. Yes. Correct. Not, look. As we know, work is equal to Fs, or the dot product of force and displacement. And then that is Fs cosine of theta. Okay, if this is 0, the rest product will be 0. So the same thing holds true. If force is 0, the product becomes 0. If the angle between them is 90 degree, or if they are mutually perpendicular, that means 90 degree or pi over 2, cos pi over 2 becomes 0, and then work becomes 0. And our answer is D. Explanation about it. Work is calculated as the dot product of force and displacement. If any of these factors is 0, or if they are perpendicular, the work then is 0. Great. Number 11. A car is accelerated on a level road and attains a velocity 4 times of its initial velocity. In this process, the potential energy of the car is says, look, my dears, the car is accelerating on a level road. No variation in height. If there is no variation in height, how we can talk about what we call it a potential energy? To talk, to deal, to illustrate about the potential energy, there should be change in h or height. Still, the car is accelerating on the level road means change in h is 0. Therefore, we cannot have the right to deal about the potential energy of the car. And as we will see the alternatives. Or A says does not change. Yeah, the potential energy does not change because change of H is 0. And hence we never expect the change of what we call a potential energy. It will stay as it. Okay, because the car is accelerated on the level road. Make now በሌቭል ሮድ ነው እየተንቀሳቀሰ ያለው። ያ ማለት የከፍታውን መጠን እየጨመረ አይደለም እየሄደ ያለው። Okay? Great. B becomes 4 times that of the initial. No. C becomes twice to that of the initial. No. D becomes 16 times that of the initial. No. We never expect, whatever the figure says, we never expect such variation. Why for? Because the car does not change its position or h. Still the car is taking its path within a level road. Therefore, we never expect a potential variation. So the answer is A. Good, look, the explanation here. Potential energy depends on the height of an object. Since the car is moving on the lower road, its height remains constant, and then therefore its potential energy does not change. Great. But kinetic energy, as you know, half times m times square of v. And then potential energy, as you know, mgh. Because the car is taking within the level road. That means change in h is 0. Therefore, we never discuss about the potential energy, but we have the right to illustrate, to discuss, to narrate about the kinetic energy. That's all about. Thanks a lot, my dears. Till the next discussion, I'm interested to say goodbye. But don't forget, like it, put your own comment, and then share my channel for others, and then subscribe it. Bye bye, my dears.